All right. So lesson 68, we're going to start today. We'll finish up on Monday, is on exponential functions. And these will very closely resemble our geometric sequences from this week. So when you're graphing an exponential function, what I would suggest is picking a few points and some points that are pretty easy to work with, relatively small, like x being -1, -2, 0, 1, and 2. Then plug them into your function to find the corresponding y value, and then you'll have an ordered pair, and you can plot those points, and you'll have a pretty good idea of what happens with the graph. So that's what I'm going to do. Our textbook calls these the 5 amigos, but you know, I'm just going to call them -2, -1, 0, 1, and 2. So what we're going to do is we'll do 3 examples, and these are actually examples that are part of your assignment. So, it'll save you a little bit of work for your homework. So here we have f of x is equal to 2 to the power of x. And a couple of different ways that you could find the value of the function. One way would be to use a calculator, and you can certainly do that. We're going to have 2 to the power of -2. So I just type that in, 2 to the power of -2. If you have a different calculator, you may need to use parentheses around the exponent. So just be aware of that. And 2 to the power of -2 is 0.25 or 1/4. I'm also going to do 2 to the power of -1, and then I'll go write them on my page. That is 0.5 or 1/2. So this was 1/4 or 0.25. This is 1/2 or 0.5. 2 to the 0 power, any whole number to the 0 power is 1. 2 to the first power is 2, and 2 squared is 4. So if I try to plot these, that's what the plot looks like. The thing with exponential functions, if it's just a number to a power, there is an asymptote at 0, at y equals 0. So it will approach the axis, but not cross it down this way. And then it goes off to infinity that way. So there's our graph for 2 to the power of x. A couple things to remember. A negative exponent moves our base down into the denominator or takes the reciprocal. So that's why 2 to the -2 was 1 over 2 squared, or 1 over 4. 2 to the -1, 1 over 2 to the 1st, which is 1/2. So what happens if we have x equals 1/2? F of x equals 1/2 to the x power. This is going to be 1, 0 to the 1/2 to the 0 power is 1. 1/2 to the first power is 1/2. 1/2 squared, 1/2 times 1/2 is 1/4. 1/2 to the negative first says take the reciprocal of 1/2. So we flip it. It becomes 2, and then take that to the first power. 1/2 to the negative second, again, we'll flip the fraction, and then the exponent becomes positive, so we get 2 squared, or 4. And what you'll notice is we get a mirror image of our previous function. Let's see if I can sketch. Ooh, I was going okay until the end there. Like that. So one thing to look at, or maybe to notice, if our base, the thing we're taking to the power of x, is greater than 1, it's going to grow as we move from left to right. If it's between 0 and 1, it's going to decrease as we go from left to right. So this first example is called exponential growth. Again, it would follow that geometric concept that we talked about this week. This one is called exponential decay. Also geometric, but going down. So this would be where our common ratio was a fraction. One other that I want to look at is this function with the base e. And e is a fantastic base. It's used a lot in calculus. But in my mind, it's used when things are changing continuously. So for this one, I am going to use my calculator because e is an irrational number similar to pi. So finding e to different powers is a little more difficult. So I'm going to clear this, and we'll do E. So that's second, and the LN button on the Texas Instruments calculators to the negative second. Again, you may need parentheses around that exponent on your calculator. And that's about 0.14. We'll say a 0.14. Now we want to go E to the negative first. And that's about 0.37. E to the 0, just like any other positive value to the 0 power, just 1. E to the first is 0.272. I need to write these down, or I will not be able to recall them. And then E squared. E squared is 7.39 if I round. So just approximate values. Again, E is an irrational number. It does not repeat a specific pattern. It does not terminate. So as I said, similar to pi, which actually you'll be asked to use pi as your base in your homework for one example as well. So if I graph that or fill in my table, so 1.2 0.14, I'm sorry, 0.14, 0.37, 1, 2.72, 7.39. So that is the graph for e to the x. So the first half of your assignment, this are the 3 of the 8 graphs that you will need to make. The others just have different bases. Then the second part of your assignment are translations and transformations of that graph. So just to remind you, here are all the different transformations. If we take that base to a power and add something after it, that's going to shift us up. If we subtract something after it, that shifts us down. If we take that base to x plus a value in the exponent, so here the b would be in the exponent, that is going to move us to the left. If our exponent is x minus a value, that moves us to the right. Taking the opposite of the function, so that would look something like this. That would be the opposite of 2 to the x. The placement of the negative is important. That's going to reflect over the x value. If we did 2 to the opposite of x, that would be over the y-axis, a flip over the y-axis. If we combine the two, that would move us, rotate us 180 degrees about the origin. A number times our function is going to stretch our graph vertically. If we divide our function by a value or multiply by 1 over a value, that compresses our graph vertically. If we take our function and plug in b times x, so in this case it would be like 2 to the power of 3x. That is going to compress horizontally, so it's going to stretch it out. It's going to compress it horizontally, bring it together. And if it's x divided by b, that's going to stretch horizontally. That's going to widen it out along the horizon. So just keep those in mind as you work through these. These are the exact same transformations that we did back in chapter 9. So you can always refer to that. You can refer to these notes. You can refer to the chapter 9 notes. That's where they are. So your assignment on page 481, 68A, 1 through 8, those are just basic exponential function graphs. And then 1 through 16 and 68B will be those basic graphs, but translated. So if you have the graph drawn in part A, that makes it very easy to apply the translations. So it shouldn't be a whole lot extra work. Some of them will be, some of them I think will be pretty easy for you to do. Hopefully all of them are easy for you to do. Just a reminder that we will start back in hybrid on the 15th of March. So trimester 3, at least for the start, will be hybrid. Hopefully, things work out well and we can end the year with in-person teaching. Have a great weekend, and I'll see you next week.